Hi, my name is Feng. The article I choose for reading assignment 4 is Smart Detour, Defining Black Hole and Content Poisoning Attacks in IoT NDN Networks. In this presentation, I'll first review some of the related terms, then introduce the main questions and main idea. After that, I'll talk about the strengths and weaknesses of the idea, and I'll end with the possible improvements. Let's begin with review of the terms. First, named data networking, which is also known as NDN. It is a future internet architecture which was designed to replace TCP/IP because of the insecurity, poor reliability, lake mobility, and poor flexibility issues exposed by TCP/IP. Compared with the data transaction method of host-to-host of TCP/IP, the central idea of NDN is to mocus the content centered on the data packet. This improves data mobility, transfer speed, and also the security. Second, black hole attack. It's a kind of denial of service attack. Because of this attack, the router that is supposed to relay the packet will drop the packet. The other attack that will be covered in today's presentation is content poisoning attacks. This attack puts invalid content into the router, which will lower the efficiency of information transaction. Then, let's turn to the main problem focused by this paper. As I mentioned in the previous section, NDN is designed to replace TCP/IP as some leak of TCP/IP was discovered. Different from the TCP/IP, NDN is not sending data packet from host to host. This improves the efficiency of transaction and lower down the cost. But every coin has two sides. The data-oriented architecture of NDN presents new attack phase. Attacks against the framework appeared. They include, but are not limited to, flooding of interest attacks, cache pollution attacks, and attacks that method mentioned in this presentation focused on, black hole attacks, and content poisoning attacks. Will NDN be applied to Internet of Things? These attacks will make facilities no longer working. This question was important at the time of publication because existing methods cannot effectively handle both attacks. It's still important for nowadays as NDN is undoubtedly important as a networking architecture that will be heavily used for the Internet of Things, and these attacks still affect many users for nowadays. Then, let's talk about the main idea. There are some limitations of the current mitigation approaches. One method is to transfer data packets by success rate. However, drop interest packets not only affect the node that cause failure, but also lead to the decrease of trust level of all nodes that relay the packets, which will lead unnecessary detour as the trust level of nodes that have highest efficiency may be lowered. Detect availability of each package is also a possible way, but it was not affordable for down the check for every single received data package. There are also some other existing methods, but they all lead to unnecessary detour which decrease efficiency. This paper introduced a defense mechanism called Smart Detour. This mechanism will deal with black hole attacks and cache poisoning attacks in a distributed manner. Router will deal with attacks activities such as package loss and data damage. In order to avoid the unnecessary detour, authors developed two components for this method. The first part is a mechanism to calculate the probability of reception and forward the data according to the algorithm. And the second part is an algorithm which will actively update the data acceptance candidate credit. The first part we will transmit the packet to router that with maximum efficiency, and the second part calculates trust level of router that this data changes with the current situation. Let's then turn to the strengths and weaknesses. I'll cover 3 strengths and 3 weaknesses. I think it's important after reading the article. First of all, it has a lower package loss rate compared to MDFP and ROM, that is, other solutions proposed previously. This is very important because while ensuring security, whether the data is successfully transmitted is also important. Also, as the key packet's loss rate being lowered, resources which were used to send the request of the packet and send the package will also be lowered. Second, it is more efficient. According to the author's experimental, MDFP caused the necessary jumps. But since Smart Detour includes an algorithm which automatically updates trust level and releases trusted routers which may have the highest efficiency. Therefore, efficiency of the transaction will not be decreased due to security level issue. The efficiency will also be improved at the packet loss rate being lowered because less resend being requested. Third, in the author's simulation experiments, Smart Detour successfully detects 98.6% of the attacks, which is very important because wrong detection will consume more resources. This improves that Smart Detour not only behave well on mitigation, but also good at detection, and shows that Smart Detour is a good substitution for existing methods. And for the weakness, first, while the detection lead to problem of false positive and end up with packet loss or damage, the detection of the method can detect 98% of the attackers, but the strict detection method may lead to false positive issue. If the highest efficiency packet is incorrectly marked as an attacker, the trust level will be reduced. It may be possible that the second rank package could be an attacker and cause data loss or be compromised, or also lower the efficiency. Second, although the author's experiment constrains at least 2,000 data packets, however, in the end, as a networking architecture that may be deployed globally to support IoT, can Smart Detour support the transmission of a large amount of data? Third, since the credit rating will be restored after the identification error is found at the time, then in the case of a large amount of data, will the detection time be too long and eventually time out, resulting in packet loss? These problems still exist now, because this scheme is proposed in 2021, and it is difficult to find relevant information on further optimization and further promotion of this method. Let's end with some possible improvements. As resorting the credit rating after missed identification requirements additional attack actions. Is it possible to delay recovery and save time by canceling recovery operations? That is, do the restore once at the set time point, instead of doing that every time after detection. At the same time, if the data transfer completes before the time point is reached, the restoring could be done after the transaction, so that the time to recover the data packet will be saved. This may lead to unnecessary detour as routers are not released in time, but there may be a balance at the middle which can further increase the efficiency and lower the cost. Here are some additional information. At the left is QR code for the original article, and for the right is a paper version of my reading summary. If you have any questions, please feel free to email me about anything you want to know or you want to discuss. And this is the end of my presentation. Thank you so much for listening.